Okay, let's do a final exam review. So this is from 2025. So 13 questions in total. In class time, it's supposed to be 125 minutes, but for online one, I give you 2 hours to do that. And it's the same process. You need to write down your statement. So you are the one who's doing the exam. And then you need to show all your work to get full credits. So let's see the questions. So the questions will cover limits, differentiation, and integration. So everything. So the first 2 questions is talking about limits. So we want to find the limits when x approaches to -2 for this rational function. If we plug in -2 directly, let's see the denominator. So we get -2 squared minus -2 minus 6. -2 squared positive 4 minus -2 plus 4. So we get a 0 in the denominator. So we cannot just plug in -2. Right? So we have to do something. So hopefully we can simplify this. So if I don't want to carry the limit with me all the time, I just do this arrow. I do not write down equal sign. If I write down equal sign, I have to carry the limit with me all the time. So I don't want to write so much. So what I do is I just write an arrow sign. Or maybe even without the arrow sign. I just saying, okay, I'm doing some calculations. I'm not equaling them. So I don't have to carry the limit sign. So the numerator I can factor out as x times x plus 2. The denominator I can factor out as x minus 3, x plus 2. In this case, we get x plus 2 divides itself. Something divides itself becomes 1. Right? So I get x over x minus 3. So the rational function simplified to be x divided by x minus 3. Now I have no problem to plug in, right? So x equals -2, denominator is -2 minus 3. I get -2 divided by -5. So let's just get a 2 over 5. And that's it. That's the limit. So let's see the second one. The second one is x approaches to infinity. Remember, when x approaches infinity, we use something called ignore rule, which means we just ignore the lower terms. We ignore the lower terms. We only consider the leading term. So the leading term in the numerator is 4x cubed. The leading term in the denominator is -8x cubed. X cubed divided by x cubed becomes 1. So left with 4 over -8. That's the -half. Right? So that's the answer for the second one. We use ignore rule. When x approaches infinity or negative infinity, we just ignore the lower terms. We only take the leading term to consider. Okay, 3, we want to differentiate functions. So we want to find a derivative of f. So first, we're going to deal with this exponent. So 4, whatever inside the parentheses is, I just copy down. Then 4 minus 1, that's raised by 3. Then I consider the inside. I differentiate the inside the parentheses. So I get a 6x squared minus 8x, and that's it. I don't need to do anything else. I just leave like this. For the second one, we want to differentiate g. Right? So g prime equals first I see ln. ln derivative is 1 over whatever this value is. So 1 over 4x cubed plus 2e to the -3x. Right, that's firstly to deal with ln. The secondly is find a derivative of inside. And that's going to be in the numerator. So that's 12x squared minus 2 times 3, -6. Oh, why I read -3? right? Because when we take a derivative of this, we have this term, but then by chain rule, we have this -3, multiply this -3. So I just multiply 2 with a -3, I get -6. Then e to the -3x. And that's it, we don't have to do anything else. Let's see, 5. 5, we want to find a derivative of g, then evaluate at e, the Euler number. So we cannot forget about that, okay? We differentiate, then we evaluate. So let's differentiate first. So g prime of x equals, I can rewrite this function as ln x multiplied by x cubed, raised by -3, right? Or you can use quotient rule. Use the quotient rule. So I read as product, then apply product rule. So I differentiate the first one as 1 over x. Then I multiply by the second one. Well, the second one is still 1 over x raised by 3. Then I differentiate the second one. Well, how do we differentiate x raised by -3? First, we pull -3 down. Then we minus 1 from -3, we got -4. So we get -3 over x raised by 4. So that's why we have negative sign. So -3. Well, the first term is ln x. We still have to multiply by the first term. Then divide by x raised by 4. But this is also x raised by 4. So if you want, you can write it as 1 minus 3 ln x divided by x raised by 4. Then we need to evaluate at e. So evaluate at e, x equals e. So we have 1 minus 3 ln e divided by e raised by 4. Well, remember what's ln e? Ln e is 1. So 3 times 1 is still 3. So we get a -2 over e to the 4. So these are 2 steps, okay? We differentiate the function, then we need to find, then we need to evaluate at the constant e, Euler number. Well, let's say 6. We need to differentiate the function, then evaluate at 1. Right? So this looks like a very complicated. So what do we do? One beautiful thing with ln is we can rewrite the function. Right? The numerator, we can split it into different logs. We can split it into the numerator, we can write positive term. We have x times e to the -2x. And denominator, we get negative term, negative ln 2x plus 1 squared times, well, this is a negative. I can write it, I can split, I can keep splitting. Minus ln x minus 2 raised by 3. Right? Remember, that's a property of logs. So this is ln followed by this expression. In the numerator, I can split into ln. The denominator, I split into negative ln. Actually, the first one, I can also split. Right? The first one, I can split into 2. I can split as ln x plus ln e raised by -2x. Let's do that. Let me erase this. Because if it's multiplication, I can split into plus. If it's division, I can split into negative. So I can split as ln x plus ln e raised by -2x, then minus this, right? So this 2 is product in the numerator. And this 2 is product, but in the denominator. So in the denominator, I get negative. Then I take a derivative. So after this, I take a derivative. The job is much easier. ln x, derivative is 1 over x, derivative of ln. Actually, this one we can simplify. What is ln? Let's write on here. What's ln e raised by -2x? Remember, this one we can pull up front. So we get -2x ln e. What's ln e? Just 1. So that one just -2x. So this term is -2x. So what is the derivative of -2x? Just -2. Right? The third term maybe a little bit more, so minus, we'll keep the minus sign. First, we deal with ln, right? So that's the 1 over whatever the parenthesis is, plus 1 square. We don't really need to write down this 1 because we're going to multiply by something. Because by chain rule, we have to take a derivative of the inside. We have to take a derivative of 2x plus 1 squared. What is the derivative of that? The 2 times 2x plus 1. Then the exponent minus 1 just becomes 1. Then multiply by the derivative of inside, which is 2. So we get a 4x plus 4, right? Oh, actually, we get an ax plus 4. If we can keep the 4 outside, we can write as 4 times 2x plus 1. So we write as 4 times 2x plus 1. And we see this can be simplified. Right, so 1 over x minus 2 minus 2x divided by 2x, 2x plus 1 divided by 2x plus 1 just becomes 1. So simplify as 2x, 4 divided by 2x plus 1. And this term is similar, the last term. So we get 1 over x minus 2 raised by 3. Then we take a derivative of this. We get a 3 times x minus 2 squared. Right? So then x minus 2 squared simplify with x minus 2 cube. So minus 3 divided by x minus 2. We just leave like this. All right. Oh, we have one more step because we need to evaluate at 1. So now we're going to find the derivative of the function at 1. So 1 over 1 minus 2 minus 4 divided by 2 times 1 plus 1 minus 3 divided by 1 minus 2. So I have 1 minus 2 minus 4 over 3. 1 minus 2 is negative 1. Negative and negative become positive, so that becomes plus 3. So I have 1 minus 2, negative 1 plus 3. That's 2. 2 minus 4 over 3. 2 we can rewrite as 6 divided by 3 because we need a common denominator of those two terms. So in the end, get a 2 over 3. So this one is quite tedious. So we need to use the property of logarithmic, right? If the inside is a product, we split into sum of logs. If it's in the denominator, we split into negative. Then we go from there. Let's see 7. So we want to determine the slope of this graph, right? We need to use, because it's not a function. It's not a function, it's an equation. We need to use explicit differentiation. So when we differentiate x, we keep is the same as differentiate functions. But when we differentiate y, we need to attach y prime. So keep 2 outside. We'll take derivative of the first one, multiply the second one. Derivative of x is 1 times y. Then we take derivative of the second one times the first one, or derivative of y is y prime. Then we take a derivative of this e to the xy. First, for the e term, we always have itself, but then we have to multiply by the chain rule. So this one we have to take product rule, right? So the product rule we differentiate this product rule of xy we already did, which is y plus xy prime. Then equals to 0. Derivative of 4 is 0. Now let's spend out. So I have 2 times y, 2y, 2 times xy prime. Then e to plus, this is plus, e to the xy times y plus e to the xy times x times y prime equals 0. Now we need to find common like terms. So this one has y prime, this one has y prime. We want to group those two together. So I have 2xy prime plus e to the xy times xy prime. equals to, we move all others to the other side. To the other side, then they all become negative. So negative 3x squared minus 2y minus e to the xy y. Right now, I have y prime here, y prime here. I can factor out. I can factor out y prime outside, right? I can write down y prime outside. Then I divide both sides by 2x plus x. I'm writing the x up front. X times e to the xy. The negative sign, you see the numerator, everybody has a negative sign, so I'm going to write down negative sign up front. So negative, the numerator is 3x squared plus 2y plus y times e to the xy. All divided by 2x plus x e raised by xy. Okay. Then we want to determine the slope at this point. So the x value equals 1, y value equals 0. So 1, 0, we need to evaluate. So only x survives, right? With the y term, because y is 0, so this becomes 0, this becomes 0. Only the other term. And okay, so let's write it down. So negative 3 times 1 squared, 3, divided by 2 times 1, 2, then plus 1 times e to the 0. Well, what is the e to the 0? E to the 0 is 1. 2 plus 1, 3. So this is just negative 1. So slope at 1.0, tangent to this curve, is just negative 1. Let's say 8. So relative extrema, which means we need to find the critical numbers. Or maybe critical points. Points means x, y value. Critical number means only x value. So we're going to use derivative set to be 0, right? So let's find derivative of this function. Well, we have a product. So we take a derivative of the first one. Right? We get a negative 3 e to the negative 3x. Then multiply by the second one. Then we take a derivative of the second one, multiply by the first one, or derivative of the second one, just 1. Then we set this one to be 0. So have this common term, e to the, right? So let's factor out that e to the negative 3x. Then the first term left with a negative 3 times x minus 2. So negative 3 times x minus 2. And this one left with only 1. So 1 times e to the negative 3x equals that, right? So equals 0. So we divide by this term on both sides. 0 divided by anything will be 0. So we have negative 3 x minus 2 plus 1 equals 0. Now we can distribute negative 3. Negative 3x plus 6 plus 1 equals 0. Negative 3x equals to negative 7. X equals to 7 over 3. Okay. So we just have to do step by step. We see two functions, product of two functions. We use the product rule. Okay, let's see 9. Anti-differentiate or evaluate the integrals. So this is the indefinite integral. So after we finish, we should just add c to it, get a family of functions. So anti-differentiate 6x squared, we get 6x raised by 3 divided by 3. Right, this is 6x raised by half. So plus 6x raised by half plus 1 divided by half plus 1. Then minus 3x plus c. We'll simplify a little bit. 6 divided by 3, that's 2, 2x cubed. Now this one we have plus 6x square root of x, right? X square root of x, that's x raised by 1/2 or 3/2 or 1 plus half, all right? Then divided by 3/2. 3/2. Right. So divide by 3/2 is same as multiplying 2/3. Minus 3x plus c. And this time we can simplify, so this becomes 2. In the end, we get 2x cubed plus 4x square root of x minus 3x plus some constant we don't know. That's it. So we get a family of functions. Well, let's see this one. Number 10 is a rational. So we need to use u-substitution. So we let u to be the denominator, x raised by 4 minus 3x squared plus 5. Then we need to find a du dx. So du equals to 4x cubed minus 6x, and that's it. Remember, we have attached dx, right? Because usually we write on du dx, but now we just multiply dx on both sides, so we can write this way. Then we'll observe. So this one, we compare this one with the numerator. The numerator, we have 2x cubed minus 3x. So let's factor out 2. Factor out 2, we get 2x cubed minus 3x dx. Now, this matches what we have in the integrand, right? So in the integrand, we do have this 2x cubed minus 3x dx. So we can rewrite this one as, so this one in the denominator, but remember this is substitution by u, we just have 1/u du, but we have this 2. This 2 we can leave outside. So we anti-differentiate. Well, 1/u anti-differentiate, we get ln u. Remember this, right? Ln x. When we take a derivative, we get 1/x. If we do the other way around, 1 over something, we get ln of something. So 1/u anti-differentiate, we get a ln u. Then this is an indefinite integral, so we need to add constant c. Now we can substitute u back. So there's a 2 ln x raised by 4 minus 3x squared plus 5. Then add a c to it. And that's it. Again, we get a family of functions. So it really depends on c. So 11 is similar. We're going to use u to substitute this one. Then we see du. So let's write down du outside. 6x raised by 5 plus 12x squared and dx. Right? So this one we can factor out 6. So I get x raised by 5 plus 2x squared dx. And this is exactly this. Oh, hold on a second. I made a mistake. So here we multiply. So here is 2 multiplied by this. We need to divide by 2 on both sides, right? So we have du divided by 2. So this is 1/2 instead of 2. Same thing here. So both sides we need to divide it by 6. So we got du divided by 6. So this becomes 1/6, right? U raised by 3 du. Du. Because du over 6 equals this. So we pull 1/6 outside. Now we can anti-differentiate this. That's u raised by 4 divided by 4. That's u raised by 4 divided by 4 times 6, 24. Then we substitute u back. U is x raised by 6 plus 4x cubed plus 1. And this one raised by 4 divided by 24. Then in the end, we add C to it. We add C to the, oh, hold on. This is not adding C, right? This is not indefinite integral. We evaluate from 0 to 1. So we want to evaluate this from 0 to 1. Remember this was evaluate at 1. So we got 1 raised by 6 plus 4 times 1 raised by 3 plus 1 divided by 24, right? Then this one raised by 4 divided by 24. Well, at 0, what do we get? At 0, the x term cancels out. So 1 raised by 4 divided by 24. But 1 plus 6, 1 plus 4 plus 1 is 6. So we get 6 raised by 4 divided by 24 minus 1 over 24. Well, what is the 6 raised by 4? 6 raised by 4, 6 squared is 36. So 36 times 36, 200. Huge number, right? 1296. I hope I did not make a mistake. Then minus 1, we get a 1996 divided by 24. Of course, we can use a calculator to get a decimal value. Right. So 10 and 11, we need to use the u-substitution method. And 10 is an indefinite integral, so we just add C to the 1. But 11 is a definite integral, so we need to evaluate at 0, evaluate at 1. Let's see question 12. A population increase at the rate of proportional to the present population size. So that gives us an exponential model, right? Remember exponential model, let's say population is P. P prime always is like a scalar of the original function P, not R. Population function, right? So which means the derivative function, if it's an exponential model, the derivative always contains the scales, the original function. So this is given the initial population is 120. Remember if we have a function of exponential function, we have a times b raised by x. This a we call initial value. Initial value, which means when x equals 0. So b to x. So initial population is 120, and the population doubles in 6 years. Doubles in 6 years. So determine the growth rate. So we need to find out the P prime. And time required to the population to reach 400. So this has 2 parts. This has 2 parts. Okay, so how do we do this? It doubles in 6 years. So which means 2P, let's call P like the original one, right? 2P, it takes, we use the formula. Remember we have this KT, right? If we talk about time, f of t equals KT. So we need to find the constant t. That's the model. KT, right? And of course, this is the original one. So initial value is 120, right? The base, we do not know the base. Do we know the base? We don't know the base. But we know it doubles every 6 years. So this is 6. So it takes 6 years to double it. But maybe we don't need to involve t. Well, let's make a simple one. Let's redo this, right? So we start with population in terms of time. That equals the A times the base raised by years. And it takes 6 years to double, which means an initial value is 120, which means 120 times the base raised by 6. That's gonna be twice Well, what is the twice of 120? 240. Of course, we can simplify this, right? Because 120, if 120 is 1, 240 is just 2. So b raised by 6 equals to 2. So we need to find the b, the base. What do? We can take logs on both sides. Or we can rewrite as log. Remember this? How do we write as log? We write as log. Oh, it doesn't really matter. Let's take this. Either way, right? Either way. So let's just rewrite. Remember, if you have 2 raised by 3 equals to 8, you can write as 3 equals to log base 2 of 8. So let's see if that helps. So we can write 6 equals to log base b of 2. That's not going to help us because we have to change it one more time. Let's just take ln. So take ln on both sides. Now, so this is 6 lnb equals to ln2. Maybe better introduce kt, right? Kt. Let's see. So ln2 equals this. So what's lnb? So we have to use a calculator to get this value. That's ln2 divided by 6. Right? Then ln, that's e. So e raised by this value, what is b? B is e raised by this value. Whatever this calculator gives you this value. So ln2 divided by 6. So once we have this, we can write down. Right? So p of t equals to 120 times this base. Let me just write down ln2 divided by what do you call it? 6. Right? You see that's the k. It's k. All right. Then how do we reach? So how long it takes us to reach 400, which is equal this one to be 400. So we have 400 divided by 120 equals to e raised by this kt, ln2 divided by 6t. You can calculate this as a value, right? So simplify this, then simplify by 4, 10 over 3. Then take ln again. So ln 10 divided by 3 equals to ln2 divided by 6 times t. Then ln e just becomes 1. So what's the t in the end? T is ln 10 over 3 divided by ln2 divided by 6. Of course, you can always calculate, all right? Use a calculator to calculate this. Okay, lastly, we're given 2 functions. And we want to find the area bounded by those 2. We have this one, we have a line, this is upward parabola, this is straight line. So we want to find area those 2, formed. So what do? We need to find the lower limit, upper limit. Right? Remember what? So AB, the upper one, x plus 9 minus x squared plus 2x minus 3. Then dx. So we set up like this. But how are we going to find a and b? We equal to those 2 functions because the intersection points shared by those 2 functions. That means at those 2 points, the 2 functions are equal. So we can do x squared plus 2x minus 3 equals to x plus 9. So we subtract x on both sides, we get x squared plus x. Then we subtract 9 on both sides, that's minus 12. Then we can factor this to be x plus 4, x minus 3. By zero property, you can split them. Now we solve this, x has to be -4. We solve this, x has to be +3. So this one, x value equals -4. This one, x value equals 3. We don't care about the y value, okay? And for this question, we don't need to calculate the y value, the function value. So now our lower limit is -4. We change a to be -4. Our upper limit is 3, right? So the inside, let's simplify. Inside, we have x minus 2x, that's -x. Then we have 9 minus -3 become 9 plus 3, that's +12. Then minus x squared dx. We anti-differentiate first. So negative x squared divided by 2 plus 12x minus x cubed divided by 3. Evaluate at -4, evaluate at 3. At 3, we get -3 squared, which is 9, divided by 2, plus 12 times 3, 36, minus 3 cubed, divided by 3, 3 squared, which is 9. Then, evaluate at -4, we get -4 squared, +16. -4 times 12, -48. Then -4 cubed is still negative, negative become positive. So 4 cubed, 64. 4 times 4, 16. 16 times 4, 64. Divided by 3. Now let's see this. We have, so -9 over 2 plus 36 minus 9. Minus become plus. 16 divided by 2, that's 8. Minus become plus 48. Minus positive becomes negative. All right. What else? That's it. So we need to calculate. So -9 plus 8, that's -1. 36 plus 48, that's 84. 84 minus 10, 74. Because this is -9. This, oh no, this is already, no, this calculation is already done. Of course, you can use a calculator, all right? I may make mistakes here. So basically, I have -9 over 2, 36. So -9 plus 8, -1. 36 minus 1, 35. 35, so 83. Plus 83. Then minus 64 divided by 3. So let's put 83 up front. And for those two fractions, of course, you can use calculator, or we can multiply 3 over 3, 2 over 2 to make them have a common denominator. So I have -27 minus 128. That becomes 155. So minus 155 divided by 6. Yeah, I may make mistakes here. All right, you can use a calculator to finish that. So that's it. So for this question, we need to find the intersection of those two because the lower limit, upper limit are not given. So how do we find intersection? By equaling the two functions. Solve for x. Then the lower value will be lower limit. The bigger value will be upper limit. Okay, that's the final exam. Okay, sample.